So in this video, we're going to use some of our logarithm properties to actually solve equations. So we're going to jump right into problem number 11 here. And we have two logs with the same base that are being added together. So our property says that we can rewrite this as a single logarithm, so log base x, of, in this case, 16 times 4. We can multiply those together. So let's see, log base x of 16 times 4, I'm pretty sure is 64. So let me do a quick double check on that. Yes, it is. All right, so it's going to be 64 is equal to 2. So now that it's a single logarithm equal to a value, I can undo the logarithm and rewrite it as an exponential equation. So my base is x, my power is 2, and in this case, my argument turns into my answer of 64. So I want to solve this. I'm going to go ahead and take the square root of both sides. So x is equal to plus or minus 8, except it's not really plus or minus 8. Because it's the base, x can only equal positive 8 for this problem. You can't use the negative 8. It would be an extraneous solution. Okay? All right, so let's take a look at number 12. Okay, again, we have two logarithms here. The difference is in this case, we are subtracting them. So when we go to combine the logarithms into a single log, it's going to be log base 3 of x over 4 is equal to 2. So now it's a single logarithm equal to some number. And I'm going to undo the logarithm into an exponential. So it's going to be 3 squared is equal to x over 4. So 3 squared is 9 is equal to x over 4. I'm going to multiply both sides by 4. So what is that? 36 is equal to x. All right, that looks good. Okay, so that's what happens if you have logarithms already in the problem, right? So you can use those powers of logarithms to solve it, right? Now we're going to start looking at some problems where you don't have logarithms, you have an exponential. So 4 to the x is equal to 5. Now, since the beginning of this year, I've been giving you guys problems, and I'm going to change the problem up really quickly. And let's say it was 4 to the x is equal to, I don't know, 8 to the third, something like that. And you would have to rewrite 4 and 8 with a common base of 2 and then solve from there. The problem is, at least with this new problem, I have no idea how to make 4 and 5 have a common base. So I can't solve it that way, all right? What I can do, though, is take the log of both sides. So if I take the log of both sides, all right, we've got log 4 to the x is equal to log of, whoops, hold on, write it the right way, log of 5. Now, the logs that I'm using here are base 10 logarithms. And the reason I'm using that is because, well, my calculator can use base 10 log. So here's the deal. I'm going to use my property of logarithms to fly this power of x in front as a coefficient. So x log of 4 is equal to log of 5. And now to solve for x, I'm going to go ahead and divide both sides by log of 4. All right. Now, on my handy-dandy calculator, I am going to divide this. Now, I'm pretty sure I'm going to split screen here with Calculate 84. Let me see if I can partially. Ooh, I can. Nice. All right. This way I get a little bit more writing space. Let's go ahead and clear that out. So log of 5. Well, log right here is your log button. So we're going to do log 5. And I want to go ahead and pop outside those parentheses. So I'm going to do divided by log 4. Now, depending on your calculator, you might actually have to close the parentheses. Obviously, the one that I'm working with, closed it already, but make sure it works, okay? So I have this answer. Now, I I don't know. I make mistakes, right? It happens. So I have a tendency to check my answer really quickly. And the way I'm going to do this is I'm just going to use this answer. I'm going to store it as x. And then I'm going to take 4 and raise it to the x power. And when I hit enter, I want my answer to be 5. Oh, good. I did it right. So this tells me, this little check that I just did tells me that this answer is the right answer. Now I'm going to do a quick Okay, there's no directions here for rounding. So if there's none, I tend to round to 2 decimal places. And I'm just going to say x is approximately equal to 1.16 here, knowing full well that this actual answer is a lot more complicated than that with the decimals. All right. For these problems, I'm going to go ahead and do just the odd questions, and then I'll fill in the key with the even ones. If you have any questions or concerns on those, we can address them later on. So problem number 15, all right, again, we have 4 and 12 here as our bases. Yeah, I have no idea how to make 4 and 12 be a like base. So I'm just going to go ahead and apply my log to both sides. All right, so log and log. So this is going to turn into log of 4 to the x plus 4 power is equal to log of 12. I'm going to take this exponent and fly it in front as a coefficient. But you'll notice I'm using parentheses there because that coefficient, the whole thing is the coefficient. I'm going to be a little bit lazy here, and I'm just going to go ahead and divide both sides by log of 4. All right, so x plus 4 is equal to log 12 over log 4. And then to get x completely by itself, I'm going to go ahead and subtract 4 from both sides. So log 12 over log 4 minus 4. Okay, so I want to put this into here. All right, so let's see what we got here. We're going to do log of 12. Now, again, my calculator already popped the parentheses there. So, no, I don't need that. Okay, let's try that again. So, log 12. I'm going to pop out of the parentheses, divided by log 4. And the way I'm popping out of the parentheses, just hit the right arrow. Minus 4. And I think my answer is negative 2.2 something. I don't know, so I'm going to test it. So I'm going to go ahead and store that as x. And I'm doing that with the STO, so store x, hit enter. And then I'm just going to put in the left side of this equation. So 4 to the x plus 4 power. So 4 to the x plus 4. And when I hit enter, I want 12. I got my 12. Yay! So x is approximately equal to negative 2.21-ish. All right. Depending on the directions, you might actually use other decimal values depending on what the directions say. Again, these didn't have directions, so I'm just going with 2 decimal places. Okay, so we have 17 here, which is 3 e to the x is equal to 10. So I'm actually going to start by dividing both sides by 3. So this way I can get e to the x all by itself. So I've got 10 over 3. Now, this is actually something that I can translate into a log equation. Because it's natural, or because it's e, I can use the natural log. So this would be the natural log of base e of 10 over 3 is equal to x. So that would make x equal to, so I want to put this into the calculator. Now, ln, it does not need the base e, it just is base e. So natural log is sitting right down here. So natural log of 10 over 3. Let's go ahead and hit enter. I think it's 1.2 and change. So let's go ahead and store that and test it. So 3 e to the x should equal 10. All right. So that was an x value of approximately 1.20. Okay. All right, so I'm going to go ahead and close this video for right now. I will, on the answer key, have the odd answers. As always, if you have any questions or concerns about any of these problems, drop me a message, stop in the Zoom meeting, whatever you need to do.